Good day, my angels. Mark your own quiz. You can either watch the video or you can just mark it from the PDF file that I've attached to the email as well. And of course, we have to start off with my best, worst joke of all time. Come on, admit it. You've missed this one. Whose name goes on the quiz? Good old Ann Serkey. She gets everything right. All right, number one, how much momentum, magnitude, and direction does an 80 kilogram mass have if it's traveling at 22 meters per second north? So momentum is mass times velocity, so it's going to be 80 times 22. Well, 80 times 20 is going to be 1,600 plus 100. I think it's going to be 1,760. Let me double check. Yep, 1,760 kilogram meters per second. And then you need to include a direction. You can say the word north. You can just put a capital N. The at symbol is optional, but if you use an N, put the at symbol, otherwise it looks like newtons. I would give you half mark for the magnitude and a half mark for the direction. Number two. What is its change in momentum? Okay, change in momentum. Change in momentum is equal to final minus initial. Well, I don't know the final momentum or the initial momentum, so okay. Change in momentum is also equal to force times change in time. I do see a time, but I don't see the constant force, so I see a final and initial velocity. They're both south, so I'll call south positive. And it's going to be mv final minus mv initial. M, 220, v final, 52, minus 220, the initial, 23. This one I don't know if I can do in my head. Okay, computer, thank you for that important message. I'll get to that later. (6,380) kilogram meters per second. Direction, well, I got a positive answer. I said south was positive. So, south. Again, half mark for the magnitude, half mark for the direction. B, what's the magnitude of the force? So they just want the magnitude, the size. They don't care about the direction. I could go F equals ma and solve, but since I just found the change in momentum, I think I would probably go change in momentum equals force times change in time, which means the force is going to be the impulse divided by the time. It's going to be 6,380 divided by 58. I have no idea what the answer is. 110 newtons. If they had asked for a direction, since I got a positive answer, I would say, oh, the force must have been south. It gained momentum. It sped up. Here, I guess I would probably go half mark for the equation, half mark for the answer. 80 kilogram moving. Okay, bring him to rest. So they did give me a V final, so I'm going to find the impulse, the change in momentum, by going mv final minus mv initial, where the final is 0, because V final is 0. The initial is 80 times 18. I think I can do that in my head. 80 times 18, well, it's going to be 80 times 10, which is 800, plus 80 times 8, which is 640, so it's going to be 1440. Is it negative 1440? Double check that. 80 times 18, I know it's negative. Yeah. Kilogram meters per second. They just wanted the magnitude, so if you didn't include the negative, I don't care. I would probably go something like this. The negative means, by the way, he had to lose momentum to come to a stop. Of course the skier did. Otherwise, how would the skier have come to a stop? Ooh, now they want me to find time. Well, I think I would probably go impulse equals force times time. Since they gave me a force in the question, time is going to be the impulse divided by the force. Time is a scalar. It's a backwards force, so technically, since it's a backwards force, I should call this negative. So it would be negative 1440 divided by negative 270, which gives me a positive answer for time, which is a scalar. And I get 5.33 seconds. Pause for one. For 1 mark, I would probably give you half mark for the equation and a half mark for the answer. Number 4, impulse magnitude and direction. So impulse is change in momentum. Let's see. I see east. I'm going to call east positive. I'll call west negative. I'll put a little negative in front of the west. I'll put a little positive in front of the east as a reminder. And also 170 grams, 0.17 kilograms. Nice try. So I think since I have a final and initial velocity, it's going to be mv final minus mv initial. It's going to be m 0.17, v final negative 43 minus 0.17 positive 22. The change in momentum is going to be 0.17 times negative 43 minus 0.17 times positive 22. By the way, you could have let east be negative and west be positive. In fact, I got to be honest, I'll often let the final be positive and the initial be negative, and that gives me a lovely little minus, your cursor, gives me a little minus right there, which becomes a plus, which to me makes the math easier to do in my head, but I don't care. I get a magnitude, I get a negative 11.05, so it's going to be 11.05, 11.1 is okay, 11, I'm fine with that, 11 is okay, kilogram meters per second, direction was negative west. So for 2 marks, I would give you 1 mark for the magnitude, 1 mark for the direction. Now they want the average force, magnitude, and direction. So impulse is force times time. So force is going to be impulse over time. It's going to be negative 11.05 divided by 0.025. I get negative 442 newtons. So if you want me to give it a direction, it's going to be 442 newtons at negative was west. Or you could just put a W. And you can see why we put the at symbol, because N is newtons, it's north. If I just put a W there, by the way, that's also work or watts. We're just running out of letters. So if it's a direction, we tend to put either an at symbol, or some teachers put directions inside square brackets. I don't care. I'm lazy. I put the at symbol. I would give you 1 mark for the magnitude, 1 mark for the direction. Find the impulse. Okay. Well, you know what? They gave me the force and they gave me the time, so I think I'm going to find the impulse by using force times time. And Okay, let's see. I got to be careful. I see east and west, so I'm going to call east positive. I'm going to call east positive, so west is negative. You know what? The force is negative because if you're hitting a baseball and it ends up going west after you hit it, you must have applied a force to the west. It must be a negative force. So I'm going to put the negative in there. That's a tricky one. Time is 7.5 times 10 to the negative 3. You know what? It's easier just to write 0.0075 because that's what 7.5 times 10 to the negative 3 seconds is. So it's going to be negative 20,400 times 0.0075. I get negative 153, which means, oh, come back. All sorts of fun stuff popping up here. There we go. So the impulse is going to be, direction is negative, so it's going to be 153. You could say kilogram meters per second. I'll give you full marks. But since I used force and time, I'll write Newton seconds, since that's how I found it. That's another way to measure impulse or momentum. And if you want a direction, negative, which was west. One mark, one mark. Final velocity. Okay. Let's see here. Give me a second. B. Find the final velocity. Now, I noticed that this one is worth 3 marks, which means probably it's got an extra step in it. And knowing Mr. Dueck, I might be using my answer from A to find part. Okay, I got this. Now, there are other ways to get this as an answer, and if you get the right answer, give yourself 3 out of 3. But I would do this. Impulse is equal to mv final minus mv initial. So if you want me to get v final by itself, right there, I think impulse would drop down like a domino. I would plus mv initial over. I think I would divide by m. Hey, you know what? That's v final. Ooh. So it's going to be negative 153 minus 150 grams is 0.150. And v initial is positive 39. All over 0.15. Now, it does say that the ball rebounds west, so I am expecting a negative answer. If I get a positive answer, I'll be worried. Is this a fraction? Yep. Is there more than one thing on the top? Brackets around the top. Divided by, don't need brackets around the bottom. And I think I got a typo in here. Do I, Mr. Dueck? (153) negative 153 minus 0.15 times 39. Let me pause for a second and see if I've made a typo, because that velocity seems really high. Of course I made a silly mistake, because there's a plus sign right here, and I wrote a minus sign right here. How about I make that a plus sign instead? So how about I go negative 153 plus 0.15 times 39 divided by 0.15. Because that 1,000 and something answer, that's 3 times the speed of sound. The ball doesn't leave that fast. There'd be a sonic boom every time a baseball player hit the ball. We get negative 981, which really isn't much better. So is there something else dumb that I've done? I called east positive. Force is definitely negative, because it's got to be to the west. So I got to put the negative in here. I think I've made up some bad numbers, and I think my bad number is that the time here, I think, is too small. I think I have an impulse too big. So I'm going to use these numbers, and I apologize for some bad math. Let me just double check one more time. I'm going to pause the video. So in case you're wondering, here's what happened. I changed this number last week to a different value. That time value there, I made it larger. And by making it larger, I made the impulse larger. And by doing that, I made this answer way too big. So I apologize, because I don't like giving you nonsense answers. But we'll commit to it. A pretty spectacular negative 981 meters per second. Bad answer. Let's say this. Unrealistic. Sorry. Now it wants magnitude and direction, so it's going to be 981 meters per second west. I would give you 1 mark if I saw that you managed to get V final by itself. I would give you 1 mark for the magnitude, 1 mark for the direction. And I would apologize for a bad answer. What is the impulse, magnitude, and direction of a 2,500 kilogram truck traveling west with a constant velocity of 34 meters per second? This is a trick question, because impulse means a change in momentum. If you're at a constant velocity, your momentum's not changing. Also, because impulse can also be calculated by force times time, if you're at a constant velocity, what's your acceleration? 0. So what's the force? 0. No force, no impulse. So the impulse is 0. Because the answer is 0, if you didn't put the units, I'm not going to freak out. So that, my angels, is the take-home quiz. I apologize for the bad baseball answer. I'm going to change my original quiz right now and make the numbers better.